All right. So if we have negative 2c, what are we doing? Say again? Good. Timesing everything in 2c by negative 2. So what do we end up with? Negative 8, negative 2, 6, and 0. A lot of people just, when they see the 0, they just forget it, but it's still 0. It's still a part of the matrix. The matrix still has to stay the same. Everyone good? Awesome. All right, so that's the first sort of thing we can do with matrices. The next thing we can look at is equal matrices. So we're going to kind of do about 3 different sort of things today, and then you guys will practice as we go because they're quite simple little things. So equal matrices. All right, so equal matrices are 2 or more matrices which are the same size and each element is equal. So in this sort of question, we would tell you that they are equal matrices. We would tell you that they are the same. So an example question, and I think you guys will find this rather simple. E.g., find x and y if A and B are equal. So see how the questions told you they're equal? Can you guys see that back there? Do you want the blinds shut or you're okay? It's just probably here that it's... I need my glasses. So what's the value of x? It's just 5. What's the value of y? 6. Okay, so if they're equal, then they mean that they're the same thing. Simple? Anyone need more time? All right, last thing for today. Adding and subtracting. So to add and subtract, add or subtract, we add, I'm just going to use the word add, even though it could be add, subtract for every single one of them, okay? We add the elements in the same positions in each matrix. So I'll show you an example. Okay, to write that down and we'll look at it. positions. No, hang on, I'll show you. I was just waiting for people to write it down, otherwise. All right, everyone written that down? Okay, so all we have to do is add, so the resulting matrix is still going to be the same size. All we have to do is add the ones in the same position. So what I mean by that is if we say A plus B, then we're saying now you're going to write this down this time, but you're never going to have to write it like this again. We say 2 plus 5, 8 plus negative 2, 3 plus 4, 3 plus negative 1. Everyone see how, and so our solution would end up being 7, 7, 6, 2. So you wouldn't have to write that. That's not like working out or anything. I'm just trying to, in your notes, be able to show you what you're doing. All good? What if I said A take B? What do you think I have to do? Take it. So, but just make sure you put it in the right order. So it has to be A take B. So 2 take 5, 3 take 4, 8 take negative 2. That's probably the one where everyone gets caught, just with the negatives. Negative 1 take 3. And so A take B is negative 3, negative 1, 10, negative 4. Can anyone see any problems with adding and subtracting? Any rules which we might have to follow? Right, don't write this one down, but you try and do this. I'm just going to add in C. Don't need to write down. It's probably not big enough space. What's A plus C? Actually, do write it down. Can you write it down, please? So what's A plus C? Hey? No. Good try though. I'm glad you gave it a shot. Anyone else? You can't do it because you don't have the corresponding elements. Okay, so what do you think our rule is for adding and subtracting? They have to be the same size. The dimensions of the matrix have to be the same size to be able to occur. And we will always put one of these in there, and you need to actually say, this cannot be. Be done. I think there's an official word. I can't remember it though. I'll have to remember what it is. Okay, but it can't be done. It's not possible. Okay? With multiplying, there's even more rules. Okay? So can we just write asterisk, do something which says to add and subtract matrices, they must have the same dimensions. Now, you'll notice it didn't matter when we were timesing by a whole number. So there's a difference between these sort of things. There's timesing by a whole number. That just stays the same. That's okay. This is adding matrices. That's different, okay? Everyone good with that? Okay. So let's just try one last example. So given C equals 3, 2, 8, 4, 1, 6. I'll just make that a bit neater for you. 4, 1, 6. And D equals 2, 3, 4, 8, 1, 2. We're going to kind of put two things together now. Determine 2C plus D. What do we have to do? We do that timesing first. So we have to change C to be 2 lots of C. So we end up with, and this is a good one where you should show your working. So you do that times 2 first, then do your answer, because it would be worth 2 marks. So you want, in case you make a mistake in your timesing by 2, you still want to get follow-through marks, okay? So 2C would be what numbers if we go down, if we go across and then down? So 6, and then across, 8, then 4, 2, 16, 12. Plus, just rewrite the D, 2, 8, 3, 1, 4, 2. So that would be your line of working for your first step. So if there are 2 steps to do, you need to show what you've done. And then we can just add them together. So 8, 16, 7, 3, 20, and 14. Everyone good? All right, I'll come around and help you if you need it. We are into, so I asked you to bring Unit 1 book today. Unit 1, Chapter 6. I have a feeling that I have this chapter scanned into the OneNote, but I'll do it if I haven't. Questions 1 to 7 and 10 and 11. I'm not sure what page they are. If someone could tell me, I'll write it up. I've got the page of the old book, if anyone's got the old book. Yeah. Exercise, exercise, I think it's 1A. 6A, it must be exercise 6A. What page? 89? Page 89. Oh, it's the same for both books, actually, so that's all right. Can we get started? And if you have any questions, come and see me.